Bismillahirrahmanirrahim. Good afternoon, guys. Today we will try to explain how we can solve question like that correctly. I'm talking about the unsolved question, the homework of CRO. Let me read at first the question. Calculate the AC deflection sensitivity voltage according to the column below. I'm talking about specifically to my students. Okay. I have two columns. The first one is the different potential with volt unit. The second is deflection with millimeter units. Here we have numbers like that, 2, 4, 6, 8, 10. And at deflection, all of these numbers. Here, the electric circuit will be like that. I have the power supply with constant different potential and current. I'll hesitate and explain that in my class how we use it. By using it, we can have many different stable values about different potential, like are written there 2, 4, 6, 8, 10 from constant voltage power supply. Okay, and this voltmeter you can take this recorders, you can manage these numbers, and at last the CRO. Here we have two axes, x-axis and y-axis. Voltage will be always at x-axis. The deflection will be at y-axis. Let me decrease the screen a little bit. The theory is very important. At x-axis, each 2 centimeters at x equal 1 volt. If you take a look, each 2 centimeters at x-axis equal 2 volts, 2, 4, 6, 8, 10. It's great. And at last, at y-axis, here it's important. Equal each 1 centimeter at y equal 2 millimeter. This number is appropriate, is the better. Why? Because I have here some numbers after dots, like 8, 6, and I have numbers 10, 16. Actually, 2 can act to all of these numbers with numbers after dots and before dots, because that it's ideal number, ideal theory here. We can use equal 4, we can use equal 5, but we will have some mistake about 5.05 in some numbers, and in another number like 32.6, you will have a mistake equal about 0.1. Okay, but if you use if each 1 centimeter equal 2 millimeter or 4 millimeter, your numbers will sit correctly. 1 centimeter equal 2 millimeter at deflection. That means each 1 millimeter will equal 0.2 millimeter of deflection. Now let's see it all of these. Each 1 centimeter equal 2 millimeter deflection. That means here 10, 20, 30. And here I have 10, 16. That means 3 centimeters after 10. 20.8, that means this 20. I went up a little bit. This little bit specifically equal 4 millimeters. Why? Because each millimeter at y-axis equal 0.2 millimeter deflection. 32.6, 31.6. Here I have two irregular points. The second and fourth points are irregular points. Here, I selected 31.6 minus 20.8 divided on 10 minus 6, according to this And according to the triangle rules about slope and the theta, now the deflection sensitivity equal deflection with millimeter unit divided on the voltage with volts unit. That's the same with the slope by using the triangle rule, because the slope here equal deflection divided on voltage. By that, I can say deflection sensitivity equals slope. By that, the calculation of the slope is very important. By calculate it, we can manage the deflection sensitivity at DC. At last, equal 2.7 millimeter divided on voltage, divided on volt. Now, to manage the deflection sensitivity of AC, that will be this result multiple to root 2 to be 7.63 millimeter divided on volt. Now let's talk about the conclusion. The relation between V at x-axis with volt unit and deflection with millimeter unit is linear relation. Its kind is direct. That means when one of them increase, the other will increase too, because the relation between them is direct. At last, we noted deflection sensitivity of AC is bigger than deflection of sensitivity. That's it. See you in next video. I hope your solutions will be without any mistake. Now, see you now.